All right. Hello, everybody. Let's take a look at the topics for the next 2 days. Topics that you probably know something about already: perimeter and area. So let me give you definitions of these, and then we'll do some examples. First of all, perimeter of any shape, just very simply, is the distance around the outside. The distance around the outside of the shape. So it's a distance like miles or feet or something like that, inches, whatever. Area is the other big topic in this lesson. Area is very simply the amount of space inside. So the amount of space inside the figure. So that would be typically given in square units, like square centimeters or square feet or square yards or something like that. Whereas, like I said before, perimeter is a distance that's more like just plain centimeters or feet or yards with no square on it. To start out, the really simple example of perimeter and area, I'm going to draw a rectangle here. And we'll do something really simple with getting the difference between these two calculations. So let's say that I have this rectangle and I divide it up. See if I can get this looking kind of nice here. We'll see. I don't know. Might be iffy. Oh, man. I have to erase part of this. Didn't work out too well. Okay. Let's draw this back in there. Try to make all those pieces the same size. And that's close enough. Anyway, so if I want to calculate the perimeter of this shape, this rectangle, all I need to know is how long the sides are. Well, if you can just count and see that this side is 5, that's the length, and this side is 2, that's the width. But remember that you have also, like if you're just walking around this, if you're just walking around this shape, let's say you start right here in this corner, you're going to go 5, and then 2, and then another 5, and then another 2. So your total distance that you're going to walk would be 5 plus 2 plus 5 plus 2. 14, whatever those are, units. I'll just call them units. I don't know if they're centimeters or whatever. But now if you talk about area, now we're talking about the space inside. Let me see if I can get rid of this yellow here without erasing everything. Oh, that was lucky. So the area is the amount of space inside. So it's the number of squares that fit inside. So notice that you have 2 rows there going across, and each row has 5 squares in it. So we say the area is 2 times 5 equals 10 square units, and we write it like this, and we say square units. We do not say units squared. Okay? So there's 10 squares in there, or 10 square units, because you got 2 rows of 5 squares each. So that's a pretty easy calculation of perimeter and area for that rectangle. I'm just going to give you next some formulas for areas and perimeters of shapes that you probably already know from 7th grade or whenever you first had a little bit of geometry. So let's start with the rectangle, with the one we just did. So rectangle, if you look at a rectangle, let's just do one without numbers on it. Just use a generic formula. So the length is L and the width is W. So the perimeter of that rectangle is 2 times L, so 2 lengths, one on top, one on the bottom, plus 2 times W, 2 widths on the left and right side. So that's going to be your perimeter. And then your area formula for that rectangle is just going to be length times width, like we did on that previous screen with the rectangles inside, the squares inside the rectangle. So area is length times width. Next shape we'll consider is a square. And we know that a square is really kind of a special case of a rectangle, where all the sides are the same. So these are all going to be, we'll call them S. They're all the same. So now if you want the perimeter of that square, all you have to do is find one side and multiply it by 4. So 4 times S, because they're all the same. And just like with the rectangle, if you want the area, just take the side time, the length times the width. Well, the length and the width are both the same. It's S, so it's S times S. We'd say S squared. Next shape we want to give formulas for, and you probably know this already from a previous class, and that's a triangle. So just draw myself a triangle here, just a generic triangle. It's not any kind of special case or anything. I'm going to call those sides, we'll call that side A. We'll call this whole bottom side B. We'll call this side C. And I'm going to draw a height here. The height is not a side of the triangle, it's just how tall it is. And the height is always perpendicular to the base there. So I'll call that H for height. Okay, so if you want the perimeter of that triangle, just add up the 3 sides. So that's side A plus side B plus side C. If you want the area of that triangle, there's a formula for that. And you probably already know it's 1/2 times the base times the height. That's actually provable, and I think we will prove it later, but you've probably seen that before. So there's the area and perimeter formulas for 3 shapes. We'll get to the circle here at the end. Okay, let's go back and talk more about those triangles, because you could have a height be different things in different triangles. So let's look at that triangle, which is going to be a right triangle. Let's look at this next triangle, which is can look like this, and acute triangle. And then let's take a triangle that looks like this. It's an obtuse triangle. We'll talk more about those later. So in a right triangle, here's the base, and there's the height. So remember, the base and the height of a triangle have to always be perpendicular. So in this first situation, the height is actually one side of the triangle. In the second triangle, there's the base. The height is actually inside the triangle, and it's not part of it. It's just how tall it is. And you could also have a situation where here's the base, and the height is outside the triangle. So that's the height of that third triangle. So the height of a triangle has to be perpendicular to the base, but it could be on the triangle, could be inside the triangle, or it could be outside the triangle, depending on the triangle. Okay, let's do some examples of finding areas and perimeters. So example number 1. All right, let's say we have a rectangle. And that rectangle has a length of 17 and a width of 5. So that's side 17, oops, and so that's the length. And there's the width of 5. So it's a rectangle. You know, probably a rectangle, has all right angles inside. Okay, so let's find the perimeter. Well, remember the perimeter, you got to add 2 of those lengths in, so 2 times 17. And then 2 of those widths in there, so 2 times 5. So it looks like we have 34 plus 10. So 44 units, whatever the units are there, would be that perimeter. And then the area of that rectangle, remember we said was length times width, so it's just going to be 17 times 5. So that's 85 square units. I probably should write that in there, square units. This was units. Because people don't get the difference between square units and units. Units are just how long something is. Square units are squares. Okay, so there's a area and perimeter example for rectangle. Let's do next a triangle. For example 2. Okay, so this time I'm going to draw my triangle like this. And I'm going to call this side 4x. And call this side 8. I'm going to say the height of the triangle is 6. So the height is inside for this one. And the base of this triangle, which remember is perpendicular to the height, is x plus 1. So we got a little bit of algebra in here, but we can deal with that. Let's do the perimeter first. So the perimeter of this triangle is 8 plus, just adding up the sides here, 8 plus 4x plus x plus 1. So perimeter equals 5x plus 9. That's all you can do with it. You don't know x. Let's calculate the area. Same thing there. We don't know x, but we can at least use our formula for area. Area is 1/2 times the base, which is x plus 1. Please put that in parentheses. X plus 1 is the base, times the height, which is 6. Now remember, the multiplication can be done in any order you want, so probably it would be easiest in this case to multiply the 1/2 into 6 to get 3. And then use that x plus 1 later. And then distribute that 3. So it looks like the area of that triangle is 3x plus 3. And again, we don't know. This will be units. This will be square units. They did not tell us any units, so we'll just write that. Okay, we got one more shape to consider with perimeter and area, and that's the circle. So let's review what a circle is first. So a circle we know has a center, and then you got this diameter that goes through the center. So a diameter of a circle, I mean, we know what it is, but we'll put a definition with it. A diameter is a segment which passes through the center like you see there, with its endpoints on the circle. So the diameter's got to be a line segment which passes through the center of the circle and has its endpoints on the circle. Compare that with the radius. The radius of a circle and that's a segment oops, spelled that wrong. with endpoints on the center. Let me move that down so you can look at that at the same time. On the center and the circle itself. So the radius is that segment right there, endpoints on the center, and then the other endpoint on the circle. And then this one's a diameter. Where its endpoints are both on the circle, but it passes through the center. Okay, so another term related to a circle that we need to talk about is the circumference. So the circumference is really like the perimeter of any other shape. It's just the distance around the circle. It's like the perimeter of the circle. And circles have areas too, just like the other shapes do. Okay, so there's one number we got to talk about, probably the most interesting number in the world, and that is this number pi. And how that relates to a circle. Pi. Okay, so pi is shown by, looks like that. You've seen a pi before. And it's equal to the ratio of the circumference of the circle and divided by the diameter. So it tells you what pi is. So your calculators, your scientific calculators have a pi button, but as a geometry student, your job is to understand where that number comes from, not just by hitting a button and looking at a display. If you take any circle, it doesn't matter how big the circle is. It could be 10 centimeters or it could be 10 million miles. If you take the circumference of that circle, how far it is around the circle. So you take whatever this, you take your tape measure and you measure this, whatever that comes out to be. And then you measure the diameter, whatever that comes out to be. That ratio, when you divide the circumference by the diameter, is this number pi, which we know for some decimal places. I'll put approximately because it goes on forever, 3.14159. And the amazing thing about the number pi is it goes on forever, never repeats itself. There's no pattern of repetition of any of the digits. So it goes on forever and no repetition. It's an irrational number. There's other numbers like that too. This is just the most famous one. Okay, so what does that have to do with what we're talking about? So we're going to use this pi a lot whenever we deal with circles in geometry. And it's in the formula for both the circumference and the area of the circle. So if you take that formula I just gave you, so let's say it was pi equals the circumference, I'll just call that d divided by the diameter. I call it c, sorry. Circumference is c, diameter is d. And if I just multiply both sides of that equation by d, I got circumference equals pi times diameter. And so that's your formula for circumference. That's like the perimeter of the circle. And now we know that if you look at a circle, that d, the diameter is equal to twice the radius. Remember, if you look at these two radii right here, those two radii equal the diameter. And so we can take this formula, circumference equals pi times diameter, and replace diameter with 2r. So I'd give us C is equal to pi times 2r. We usually see it written as circumference equals 2 pi r. So your circumference usually will be given to you like this: C equals pi times diameter, or C equals 2 pi times radius. These are the same thing. Tells you how far it is around the circle. And the last thing we need to know about a circle for today's work is the area formula. I'm just going to give you the area formula. It's pi r squared. You've probably seen that before. So the only thing you need to know to calculate the area of a circle is the radius. Or if they give you the diameter, of course, you could just divide it by 2 and get the radius. Okay. Let me get one more problem done, one more example, and then that'll end this video. So let's say we have, for our first example, or whatever number we're on, example 1, a circle of radius 3 centimeters. Okay, so there is your circle we're going to calculate. And so that's 3 centimeters for the radius. And we want to find the circumference and the diameter. So first of all, circumference, let's pull out that formula, pi times diameter. So for this circle, it's pi times the diameter is 6 centimeters, so that's twice the radius. So pi times the diameter is 6. So we would say the diameter, the circumference is 6 pi. That's going to be centimeters, because remember, we're talking about how far is it around the circle, and that's a distance. That's not an area. That's a circumference. It's like the perimeter. Okay, so that's 6 pi centimeters. If your problem tells you to leave it in terms of pi, you are done. Just say it's 6 pi centimeters. If they say use a decimal for pi, just take 6 times and then locate your pi button on your calculator. They're just all over the place. And use that built-in value of pi. So you can also just multiply 6 times pi and get, in this case, 18.85, I'll round it off, centimeters. But normally we'll just leave stuff in terms of pi unless they tell us to give us a decimal. Last thing we need to know about this is the area. So the area of the circle, just go by the formula, pi r squared. So the radius is 3, it's all in there already. So area equals pi r squared, so 3 squared. So it looks like the area is 9 pi. That's going to be square centimeters. That's how you write it. But you pronounce it square centimeters. In the same situation here, if they want you to give them a decimal, you just have to take 9 times your pi button and get that answer in as a decimal. So 28.27 square centimeters for the area of that circle. All right, so that does it. So just reviewing a little bit here, we have 4 shapes that we're dealing with. We're dealing with rectangles, squares, triangles, and circles. They all have a perimeter and an area formula. The problems will be those 4 shapes. And we should be able, by the end of this lesson, to be able to calculate perimeter and area of any of those 4 shapes. All right, that does it from here, and thanks for your attention, and let's do some problems.